Um, so there's my two equations, my system. What I will tell you is if you solve both of these for y and got these into slope-intercept form and graph them, where they intersect is not going to be at whole numbers. Okay, they will be at decimals, and so these become the problems where it's nice to have another method other than just graphing, because you cannot tell where these cross at unless you solve them out for So, what does substitution mean? Replace. So let's say you got Cameron playing basketball, and he goes up for a rebound, and he misses it, and just stops him upside the head, and he knocks himself out. Somebody's got to go in for him because he can no longer stand it. Right? So they substitute somebody in. Now, since Cameron's ball handling abilities are really, really, really good, they call him a guard. Okay, maybe not. So, Cameron will be a post. So who are they going to replace Cameron with? Another post. Somebody who hopefully, well, in Cameron's case, is a little bit better than him. But, no, you want somebody that's equal, or at least equal positions. If you take out a guard, you want somebody else that can dribble to go in for that person. Because, it's nice to have somebody that can dribble. If you take out a shooter, you preferably want another shooter to go in. So you got somebody else that can score. In math, when you replace or you substitute something in, it has to be equal. You can't just substitute somebody that's almost as good as Cameron. Because, that'd be like an 8th grade player. No. But you don't want to substitute somebody almost. You don't want to substitute a number that's almost equal. It has to be equal, or you cannot substitute it in. Okay? I'll leave it on that. All right. So what I need to do is I need to know what one of the variables equals. I would love it to equal a number, but looking up there, I don't think I'm going to be able to do that. It's going to be an expression I might use. Okay. So what I'm going to look for is I'm going to look for which variable up there looks like it would be the easiest to solve for. Now remember, solving for it means I have to get it by itself. So y'all look up there and try to give me that answer. Which variable do you think would be the easiest to get by itself?
Y.
Y. In which question? In which equation? The second. Yeah. Why did you choose the letter Y in the second equation? Because it doesn't have, well, change that. Because its coefficient is 1. I've been saying it doesn't have a coefficient, but that's not true. Its coefficient is 1. So I don't have to divide by anything at the end. What would I have to do to get Y by itself in that problem?
Just subtract 2x.
Just subtract 2x and I'm done. So let's do that. Minus 2x. Minus 2x. So Y equals 10 minus 2x. So now I know an expression that is equal to Y, which means I can replace any other Y in this little equation up here with 10 minus 2x. Is that clear to everybody? So this tells me what Y is equal to. So what I'm going to do now is take what Y is equal to and replace Y in that first equation with that expression, 10 minus 2x.
Why when you subtract it, it's not lifetime?
There you go. Good job.
But isn't that two separate problems?
It's two separate equations, but it's a system, and so it's two together. We're trying to find which point these two equations would intersect. Which point would they have in common?
Why wouldn't you solve for the first one?
Because the second one's easier to solve for Y.
So it doesn't matter.
It doesn't matter which one you solve for. You're gonna whichever one you solve for, you're gonna replace that variable in the other equation. So if I had to solve for the x here, then once I got that answer, I would replace the x here with that expression. All right. So now I'm gonna rewrite that first equation, except for Y is I'm gonna put parentheses with 10 minus 2x inside. So 3x plus 4 parentheses 10 minus 2x equals 12. So at this point, all I have done is replaced the Y in that second equation, or the first equation, with 10 minus 2x, which is what Y was equal to.
So do you always have to substitute for the Y?
No, you substitute for whichever variable you solve for. So if I had solved for x here instead, I would have substituted in for x in the other equation. So y just happened to be the easiest one on this one. Okay, now, what benefit is that to us? Because that equation looks a lot uglier than the one we started with.
Yeah, we got like terms.
We have like terms now. We don't have any y's. So we've gotten rid of the y. So now we have one variable, and if we have one variable, we can find a specific value. We don't have to worry about finding a y equals 10 minus 2x. We can actually find like y equals 2. We can find a specific value. So at this point, I need to distribute my 4 because it's touching multiplied by a parenthesis. So I have 3x. 4 times 10 is 40. 4 times a minus 2x is a minus 8x. And then I bring down my equals 12. So all I have done at this point is distributed that 4. The next step, somebody mentioned a while ago, I now have like terms. Let's combine them. So I have a 3x minus 8x. So what is 3x minus 8x? Negative 5x. Good job. Equals 12. So negative 5x plus 40. I just brought down the positive 40. And I brought down the equals 12.
Subtract 40.
And now it's a two-step equation that we have solved hundreds of over the last few years. So yeah, subtract 40 on both sides. So that's negative 5x equals negative 28. And then divide by negative 5 on both sides. So x equals positive 5.6.
I thought we didn't use decimals.
When you're graphing, you can't really find the answer graphing if it's a decimal.
So we're not graphing.
We're not graphing. We're finding another way to solve because of decimals. Alright. So what have I found at this point? I found x. Do I know what y is yet? No, and similar to yesterday, when I'm solving a system, I need to solve for both variables. So I need to find out what y is. Yes,
Replace the 5.6 with the x.
well, say it the other way, but yes.
Yeah.
Replace the x here with 5.6 because the y is already solved for. So I have an expression for y. So I'm going to take this 5.6, I'm going to plug it into that x, and that's going to help me get my y. So y equals 10 minus 2 times 5.6. Y equals 10 minus 2 times 5.6. Okay. When I evaluate that, that's 10 minus 11.2, which gives me a negative 1.2 for y. So my solution is 5.6 comma negative 1.2. There we go. Talk to me about your questions. I know this isn't easy, but
After you solve, what do you do with it?
after you solve what?
After you do all that, what do you do with it?
This is my solution. So if I graphed those two lines, they would actually intersect at the point 5.6 comma negative 1.2. Did you just say this is too much? But we talked about this last year.
Nah,
Last semester.
I forgot.
Do not forget that phrase. This is too much. We don't say it. That's fine. Now, if we're graphing, it's hard to find the answer if it's a decimal. So that's why we found a different way to do this.
Okay, why
For one, because that is giving the solution. If there's two equations with two variables, then I need to know the answer for both because both of those numbers have to fit into both equations as well. So this is the only number for x and for y that works in both this equation and this equation. So if I replaced x with 5.6 in both of these and y with negative 1.2 in both of these, this one would give me 12 and this one would give me 10 if I use those two values. Those are the only two values that will work for in both equations. Is that the other side? Oh, you already used some? You got some. Alright. Second one, let's go with this. 2y, oh, sorry, 2x. Minus 3y equals 6. And x plus y equals negative 12. So same process, we're still solving using substitution. Different equations though, different system. Alright, so back to the first question I asked earlier on the first set of equations. Which variable is the easiest to solve for? Second equation will be easier because all the coefficients are 1 on the x and the y. Which variable would be easier to solve for on that one? To be honest, it does not matter. On the second equation, it doesn't matter if you solve for x or y. So,
The one on the second one first,
because the coefficients are 1, because there's no numbers with the x and y. So you're looking for the number that's for the equations easiest to solve for a variable. Now, not always is there one that's easier. You just have to choose one and maybe the other. That's when we use our next method in just a second. But for this time, the x is pretty easy to solve for, so I'm going to do that. Since I solved for y on the first problem that I did, let's solve for x on this one. So to do that, I need to subtract y from both sides of this equation. So that gives me x equals negative 12 minus y.
why is it like, yay.
I want to say something so bad.
Wait, you made it more confusing for him. I'm asking, I don't care for
I can handle it in just a question, but just don't make a I give up statement. That's what I'm trying to get rid of. Okay?
So, then the y, you got negative one, right? You gotta ask questions.
The coefficient on the y is a negative 1.
So why is it like, why is that question?
It's not. It's negative 12 minus 1y. The coefficient on the y is 1, not y. Y is not 1. The coefficient in front of the y is or negative 1. Okay, so now that I know what x is equal to, I'm going to replace x in the original equation with negative 12 minus y. So I have 2 parentheses negative 12 minus y minus 3y equals 6. And 2 in the parentheses of negative 12 minus y minus 3y equals 6.
Now you got two like terms.
Well, now I'm going to distribute. Get rid of those parentheses, and then I'll use my like terms. So distribute 2 times negative 12 is negative 24. 2 times negative y is a minus 2y. Bring down the minus 3y. Bring down the equals 6. You're not supposed to be drinking that. How half of it just leave the bottle?
You pull it out of the trash can.
Is it evaporating?
Yeah, for hiding.
Hey, leave that lid on, it won't evaporate. That way you got it for later to drink. You don't have to worry about it leaving the bottle. Alright. Okay, so I distributed the two. They gave me the what's up there in green. Okay, so the next step is to combine your like terms. So my like terms are negative 2y minus 3y. So I'm going to bring down the minus 24. Negative 2y minus 3y is a negative 5y or a minus 5y. And bring down the equals 6.
Which one's first?
No.
35.
Me.
Alright, here we go. Now add 24 to both sides. So negative 5y equals 30. And then divide by negative 5, and I get y equals negative 6. Okay, same thing we did a while ago. Now that I know what y is, I'm going to replace the y in this equation. So negative 12 minus a negative 6. So x equals a negative 6. So this one is actually negative 6, negative 6.
So really when you solve for X,
So that's the
really when you solve for X, you just, and when you solve for X, you really not finding Y, you just plugging it in and there you go.
I think it'll be like a straight line, because it's multipliable.
The equations represent straight lines anyway. That just means they happen to cross at negative 6, negative 6. So it doesn't, and they can be coming from any angle. They just happen to both intersect at that.
We're doing some more.
Well, we haven't done our other method yet.
Elimination. I thought we were just.
Now, hey y'all, listen. There's two methods we're looking at today. One's substitution, one's elimination. Now, tomorrow we're supposed to be working with inequalities. Now remember, this is not meant to teach you this whole skill really well. This just gets you kind of understanding what's going to be on the pretest on Friday. So it's not meant to be an exhaustive lesson. All right. After Friday, once we've done the pretest, then I'll probably go into a lot more detail on most things, just depending on how we do on it. Okay. So I'm using elimination, and to do this,
Is this one gonna be like the ones we just did? Or different?
it's the same type of problem, but we do a couple different steps. Okay, so this is I drew the line already. What we're doing when we do elimination is trying to get rid of or take out a variable. Okay, it's eliminate, so we're trying to get rid of it. And so what we're looking for is we're looking for a variable whose coefficients are opposites in the two equations. So in this problem, the x has opposite coefficients. One's a positive 4 and one's a negative 4. Okay? Because what happens if I add a positive 4 and a negative 4? I get 0, which means it eliminates that variable. So 4x plus a negative 4x is 0x, that x is now gone. Okay? So that's what I'm going to do. If I have the coefficients are opposites, and I just want to add the two equations together. So I'm going to combine all my like terms. At this point, 4x minus 4x is 0. 2y plus 3y is 5y. 9 plus 16 is 25. Okay. Now I eliminated the x, so I can now solve for the y. Y equals 5. Okay. It is pretty easy if the variables are already have an opposite. I do have to show you when they don't, but we probably won't be able to cover that today. Alright. Alright, so I found what y is. How do I find what x is at this point? The same way you did it on the other problem, the substitution. I know what y is. I'm going to go up here and choose one of my equations and plug in that value for y. So in that first equation, I have 4x plus 2 times 5, not 25, equals 9. There you go. Alright, so now to solve for x, I'm going to multiply the 2 times 5. So 2 times 5 is 10. And then I just solve my equation. Subtract 10 from both sides. So 4x equals negative 1. And then divide both sides by 4, so x equals negative 1/4. Okay. Now, if you divided that, actually, you would have negative 0.25, and that would be perfectly fine. Okay, I'm okay with the decimal. So my solution is negative 1/4, comma 5.
Okay. You done?
Yeah, I'm going to show you something very, very quickly, but I'm not going to go through. I'm not going to go through a whole problem.
We done.
I know what you got. Yeah, no, we can't do 4 more problems for sure, but we can get 1 more started.
Leave it alone.
All right. So this one we got 2x plus 7y equals 4, and 3x plus 5y equals negative 5.
Okay, shut up.
All right.
That's what you said.
Okay. So now do I have the coefficients the same on one of them? No. The x's has a 2 and a 3. The y's have a 7 and a 5. So to get those to be the same, what I have to do is multiply the equations by some kind of constant, some number. And what I want to do is make these the same. Actually, I want to be opposites. I want one to be a positive, one to be a negative. So what number does both 2 and 3 go into? 6. Because 2 times 3 is 6. So 2 and 3 are both factors of number 6. So what do I need to multiply 2 by to get 6? 3. Good job. Because 3 times 2 is 6, right? So this is going to be a positive 6, and I want this one to be a negative 6. So what do I need to multiply the 3 by to get negative 6? Negative 2. Good job. Okay, so this is the extra step we got to work on, and we'll do a little bit more with it. But once you do this, you distribute the whole thing. So 3 times 2x is 6x. 3 times 7y is 21y. 3 times 4 is 12. And then in the next one, negative 2 times 3x is negative 6x. Negative 2 times 5y is a minus 10y. Negative 2 times negative 5 is a positive 10. Then I can use my elimination method, and I eliminate the x. Okay. Hey, y'all, a couple of things very quickly. First, the bell doesn't ring until it rings, and that's when class ends. Do not make me talk over you cleaning up all your stuff, because none of you are paying attention at that point. Everybody, that's my alarm saying it's 2 minutes left in class. Okay, so y'all were already all getting all loud and put stuff up before there was even 2 minutes left in class. All right, so we gotta deal with that. Not yet. Let me check. I don't know what time I'm coming. Okay. So very quickly, we will finish this problem tomorrow.